All right, looks like we're going to get started here. I'm just going to do a mic check. Looks like it's working and my slide's up. So, all right, so welcome to a virtual presentation here. Our topic of discussion today is a quick fire round on who we are and what we do at Topodot. So let's get started. I'm Mike Cook. I'm the lead applications engineer over at Topodot. I've been here for 10 plus years, and I work with the support, development, and sales teams. And that means I'm not alone. So we have a dedicated team based out of sunny Orlando, Florida, to help support the Topodot community. We're a software development company, but we also provide training, support, and consulting services. Essentially a new wave of data is coming our way, lots of point cloud data, and many organizations and engineering firms have joined this community to provide the best geospatial services they can, feeding downstream operations for civil and engineering firms, as well as the electrical and power sectors, GIS databases, you name it. Our community has existed for 30 plus years, now with over 500 companies worldwide and 5,000 plus individual users. And essentially, Topodot is an industry-leading software application for extracting high-quality topographies, 3D models, and collecting assets. And this is all done from point cloud data and imagery. These high-quality CAD models meet the tough demands and quality standards required by these downstream applications, such as products offered by Bentley, Autodesk, Esri, and others. The primary application areas for Topodot include the following: transportation corridors, both rail and roadway, bridges, tunnels, general structures such as architecture or buildings, as well as the power line industry for transmission, distribution, and substations. The end goal is a high quality topographic survey, drawing, or asset collection and or model, which feeds those downstream operations. Other growing segments are the monitoring and analysis tools, which are increasing in demand, essentially just asking to pull more value out of a data set that you've collected. So we're talking about wall monitoring, vertical clearances, bridge clearances, road condition information, volume calculations, and then all this information that's gathered is either attributed and exported into a format that could be plugged into a database like ArcGIS, for example. Where do we fit into the bigger picture? Essentially, data is collected and registered to control, or that control is optional, but this is done at the system level, and these are the pink bubbles. This includes static, mobile, and airborne LiDAR data sets, which also include calibrated imagery. From there, the exported point clouds feed into the Topodot process. These are the green icons. And here we offer a complete and comprehensive workflow to help manage that data, assess the quality of it, and extract the value from that data. And most important, we extract it into the format or export it into the format of your choice. This process will lead you to the deliverables you're looking for. And remember, this process works for all data collection types. Point clouds are point clouds, even if they're mixed or overlapping each other. So just to help those who are unfamiliar with LiDAR, what is LiDAR? So it's light detection and ranging. It's a remote sensing method used to examine the surface of the Earth, essentially. So it uses light in the form of pulsed laser lasers to measure ranges or variable distances to an object. These light pulses, combined with other data recorded by the system, generate precise three-dimensional information about the shape of its surroundings. In this example, we have a mobile LiDAR system, MLS in short, that is traveling down a highway corridor, performing multiple passes. This occurs at highway speeds and is collecting millions of spatial points, along with those high-resolution photos. In this case, along the side of the road, you have a survey crew installing and locating control targets, which again are optional, but this is for the system to identify itself within the world. And these targets essentially help tie down that data for a resulting high accuracy, higher precision product. So the information can then be pulled or extracted to produce those HD maps or topography or very well located assets that you're looking for. And there's a lot of options on the market when it comes to hardware. Here's a handful of mobile systems, and they all produce data with a variety of data characteristics between them. But what they collect and how they collect usually remains the same. These are the common data set components collected and used. So point cloud data, which is the first choice here. We got calibrated images, which are very useful and important for this type of industry, as well as survey control if that's needed. And tightly aligned point cloud data and imagery is key to productivity. This means we want multiple point cloud passes to line up relatively to each other, regardless of the control network being involved. And we need the imagery to be within a few pixels of the object within the point cloud. So this is very important. The alignment is important because imagery is going to help us identify objects found within the point cloud. If you don't have imagery, you won't be able to determine sign type, cracks, manholes, those smaller details that aren't going to be available in the point cloud itself. Or you won't be able to identify most flat objects. So with your high quality data set, we're now ready for extraction. And within the Topodot environment, productivity is going to be at its highest. And the application for this setup, particularly for a mobile data set, can be applied to distribution and utility pole projects, and anywhere essentially where there's a need to locate and attribute an object to be later exported and imported into a database. So in this example, we have a mobile data set. It's a single pass, no control, dual scanner configuration, and there's plenty of detail. Okay. So let's take a look at some of the tools. And these are going to be a handful of tools that Topodot offers within its toolbox. And we're covering the common demand for topographic extraction for features like ground, paint, paint lines, curbs, drives, and ramps, as well as assets, measurements, as well as additional tools for analysis, including clearances, class detection, cross slopes, grade measurements. And if you haven't seen any of our tools in action, I'm going to show you a few here, but I encourage you to visit our website or visit the virtual booth for more information. And we are all about productivity, and we understand the balance between automation and user input. There's more value in user-friendly tooling than there is in hands-off automation. So well-defined workflows and user-friendly tooling allows for any team to scale effectively. And this is what you'll find at Topodot. So let's take a look at some of the tools in action. So how do we find, or how do we handle curb breaks, EPs, flow lines, top of curb, back of curb, guardrails, anything with a profile, really? Either, control the tool when you need it, or let the tool find the curbs for you. This will automatically find the curb profiles and then adjust all breaks accordingly in 3D space. So it's crucial to also have kind of a QA/QC process either after extraction or during extraction, both of which you'll find that Topodot offers. When making fine adjustments, we provide an easy to understand cross section. And never get into the habit of snapping to a individual point. Let the algorithms do the work for you. We see here the modification tools, that your CAD team essentially needs to properly vectorize the point cloud. Remember that point cloud is just a bunch of XYZ points in space, so we're basically digitizing these with intelligent information such as polylines or cells or points with attribution. For asset extraction, we have, so you'll notice each tool has a very specific application, and here we're going to be locating vertical assets along a corridor. So the idea is you isolate the search region down to the shoulders where you'll find most of your signs and poles. And then from there, you'll let the tool run, search for all our objects of interest. It's going to build a list for us, which we'll see in a moment. So as it searches, it's going to build that list for us. And all the technician has to do is basically skip through the list and the photography, assign any attributes, such as like feature code or height or radius or anything you're looking to collect for that, store the images with it. All you have to do is basically just step through this list and accept, and it's going to be essentially placing a cell with the attribution linked to that cell. So it's really key for vertical objects and flat objects when you're doing asset locationing to have those images as a backdrop because the LiDAR data itself does get you the overall shape in the object and you can find it, but we still need that image to produce the rich visual information that's needed to make a final specific decision on what that sign is either telling us or what that object is telling us. If we're looking to include those detailed attributes, we need that image to go along with it. All right, so let's go ahead and move on to flat assets. And in this case, flat assets are going to be our paint markings on the surface of the road. And here we have a tool that will basically search a library for you, associate the object that it's found in the point cloud with the object that's stored in the library, and it's going to apply a cell for us. Okay, so these cells could be an exact representation of the object, or it could just be a point, could be a circle, could be something else. But essentially, you're just storing that object shape, and it's associated with some type of cell. And in this case, the cell is going to be an exact representation of what that object is in the point cloud. Very slick tool. You could do it. I'll run that one more time. You can apply this, one feature at a time. So we got a 3-point method. We have a single click method, which you just have a line set up like a center line that controls the orientation, and the user just simply clicks on the object. Or if you have long stretches of road with paint lines already defined, you can use an auto method to search within lane lines for any objects that may exist. Having intensity here is key because that's what helps us identify those objects. Here we'll look at wire and attachment extraction. So now we're kind of jumping into some vectorization of line work on the power lines. So the goal is to vectorize these lines and the attachment points with a few simple steps. First, we'll locate the power poles or towers using an auto search. Give it an example pole up front and let it find the rest. So you'll check, add, and subtract as necessary. And then once you locate those poles, we'll take that pole information and it's going to be taken into a wire extraction phase. And once you build the wire pattern or template, you'll just use that to automatically find your wires. So this can be used to automate the extraction of the actual wires. And if you notice, the wires and the attachment points are being collected at the same time. So you have vectorized lines and points at those attachment locations. Let's see how we can gather more information on this feature. We're talking, relative measurements, maybe the insulator attachment points, maybe the tilt of the pole, a variety of attributes that we would like to collect. Simply set up a cross-section for a preview of the point cloud. This will automatically center itself and determine pole radius at a breast height. You'll get a top-down view of the horizontal data slice and then 2 elevation views of the pole. Within this preview, you can precisely control the tilt, the height, top radius, and more. And also use the stored attachment templates for fitment. A variety of measurements can also be taken from these points as well. You can store the closest imagery, store offsets, vertical distances, either from each other or to the ground. All this information can then be exported or displayed graphically, either via a shapefile or a CSV file. With this approach, you can extract what's needed much faster than a traditional method, which is essentially going to be you're going to be reducing data collection per pole down to a few seconds. And unfortunately, I won't be able to cover everything today. That's what our booth is for. So please check this out. We don't bite. But what we see here gives you a good idea on what else is possible with your data. And when it comes to exporting all of this extracted work, we do have flexibility on our end. Export to shape, CSV, KML, JSON file, or export a full model as a drawing file or CAD file. DGNs, DWGs, DXFs, etc. So you might be going to ArcGIS, or you might be going to like PLS CAD. You can even export the point clouds if you've decided to classify those as well. And another trick is to create a drawing sheet to help visually display the work and or the actual point cloud itself. This can be seen on the right. And a final look at the workflow, or a different look at the workflow here. Data is collected and prepared at the system level, providing high quality LiDAR and imagery. This is then fed into the Topodot environment for extracting and exporting all of your GIS assets. These deliverables can be exported in a variety of formats or prepared in a variety of formats. And then simply import those deliverables into the database of your choice, such as ArcGIS. Now on a side note here, for internal or external operations, how do the benefits of LiDAR span across those operations? So, multiple departments can collaborate on top of the process we originally just discussed. So imagine having access to data across these operations and direct communication with your data experts to basically extract what you need and where you need it. Reducing GIS collection, survey, design, and construction costs, some by orders of magnitude. The foundation of this process is provided via an easy-to-use upfront or front-end web portal, which puts the data at everyone's fingertips via a simple URL link. Let's take a look at this. So working together via a web URL means no software installs required. All data projects are displayed on an interactive map seen on the far right. And with a web project open, seen in the middle, you'll have the 2D line work, control locations, project information, aerial overlays. You'll have the point cloud coverage itself. And in this case, it's displayed in a height gradient or a hybrid of an intensity and height gradient. This is all going to be a permission-based access to the data. So you do have control over that. You can decide to share your data or not share your data. You can navigate and view imagery seen on the bottom left, where you can also take measurements such as height and width. And this is possible because the 3D spatial data has been embedded into the photo, something we call DPEGs. So these DPEGs can exist on this web portal, or you can even take those to the Esri environment for extraction as well. This web portal is essentially going to allow all parties involved to review projects, send markups directly to the CAD teams via KMLs, and to receive quicker turnarounds and or better geospatial information. Why is all this important? It allows for scalability and working remotely. The applications of LiDAR technology apply to nearly all types of infrastructure and GIS projects. The extracted work is going to be all geolocated. If you're not using control, you're going to be within a certain amount, very close. But if you are using control, you're going to be very, very precise and accurate. And then you're going to see improvements to productivity, lowered cost, and just you're going to ultimately reduce repeat trips to the field. So if you have any questions, let's talk. I'll leave you with a little bit of my contact information. Here's a few options to get a hold of us. You can phone us, visit our website, or simply email us at info@topodot.com. And if you're into socials, you can find us there as well. And thank you for your time. All right, looking at the chat box here. I don't see any questions revolving around the presentation, so I'll assume we can probably wrap things up. I'll go ahead and leave that up to